Hey guys, today we're going to be working on the quotient property of square roots. We're going to be applying this property while simplifying square roots. And it basically says the square root of a quotient. So if I had the square root of 3/4, that is going to be equal to the quotient of the square roots of the numerator and the denominator. So basically, very similarly to the product property of square roots, we're just breaking up the numerator and the denominator. So the formal rule will state if you have the square root of a over b, that is equal to the square root of just a over the square root of just b. So let's try to do an example. Square root of square root of 15 over 64, not 24, sorry about that, 64. Okay, so using the quotient property, I can rewrite this as the square root of 15 over the square root of 64. So 64 is already a perfect square, so the square root of 64 is 8, and then 15, the factors of 15 are just 5 times 3, so there's no perfect square factors. So your final answer would be root 15 over 8. The next example will be 81 over x squared. So we can rewrite this as the square root of 81 over the square root of x squared. So the square root of 81 is 9, and then the square root of x squared is x, giving you a final answer of 9 over x. Okay, let's just do a couple more. So let's do the square root of 4x squared over 64. You can break this up into the square root of 4x squared over the square root of 64. And then here's where it gets a little bit tricky, just because you have a product in your numerator. So using the rule that from the previous video, this would be the square root of 4 times the square root of x squared. And then this one's pretty easy, the square root of 64. I can go ahead and simplify that to 8. So then we have the square root of 4 is 2. The square root of the x squared right here is going to be x, and then the 8 on bottom. And then when you come to a problem like this, you want to check to see if you can simplify your whole numbers, which we can. So 2/8 will simplify to 1/4. So this will give us a final answer of x over 4. Okay, last one, we'll do the square root of x cubed over 49. This can be rewritten as the square root of x cubed over the square root of 49. So the square root of 49, that one's pretty easy. That one's 7. And then the x cubed can be rewritten as x squared. The square root of x squared times the square root of x. And then we can simplify that square root of x squared into x. The square root of x doesn't simplify, and then over 7. Okay, let's try another one. So let's do 36 over a to the 5th. So that's the square root of 36 over the square root of a to the 5th. The square root of 36 is 6. And then we're going to have to rewrite these, the a to the 5th. So we get, so we can figure out how many groups of the a squared we can get. So we have a squared, that makes 4, and then a. Okay, so we have 1a squared and then another a squared. So that means 2a's are going to come out of these radicals. That's going to simplify to 6 over a squared root a. So notice that none of our other answers that we did above had a radical in the denominator. So when this happens, this is not fully simplified. So not fully simplified. So this means you have a little bit more work to do, which we'll go into on the next slide. Okay, so like I said, when you have a radical in the denominator, it's not fully simplified. So let's do a separate example. So we have the square root of 5 over the square root of 3n. So this isn't fully simplified, and the way we get rid of the radical is to multiply the top and the bottom by the radical 3n, or root 3n. So remember, this is kind of like when you're trying to find a common denominator with a fraction. You can't just multiply the denominator without changing the numerator. So whatever you're multiplying by, you have to do it to both the numerator and the denominator. So once we simplify that, we will get to the square root of 15n. So you just multiply the 5 and the 3 and the 5 and the 3n. And then on the bottom, you get the square root of 9n squared. So now we just have to work on simplifying the denominator now, because the square root of 15n does not simplify. So this is going to stay the same. And then we can break up the 9n squared into the square root of 9 times the square root of n squared. So the square root of 9 is 3, and the square root of n squared is n. So your final answer would be root 15n over 3n. Okay, let's try another one. So let's do the square root of 7 over the square root of 2x. So remember, if we were to have been simplifying this problem, you can't have a radical in the denominator, so you're going to multiply the numerator by 2x, radical 2x, and the denominator by radical 2x. On the top, this will give me root 14x. On the bottom, it will give you the square root of 4x squared, because 2 times 2 is 4, x times x is x squared. So again, the 14x, that won't simplify into any perfect squares, so that's going to stay the same. So we have radical 14x, or root 14x. And then we can break up the denominator into square root of 4 times the square root of x squared. So when you simplify that denominator, the square root of 4 is 2. The square root of x squared is x. And the numerator could not be simplified. So root 14x over 2x is your final answer. So I just want to take a moment here and talk about any patterns that you may see or may have caught when we were working through these examples. So let's look at that first example. When we did root 3n times root 3n, after we got 9n squared and we simplified that, we just got 3n. So the same thing kind of happened with the 2x. So if I did root 2x times root 2x, that gave me root 4x squared, which just simplified to 2x. So I want you to think about how this 3n right here is related to these, and how this 2x is related to what you started with. Okay, so hopefully you noticed that anytime we were rationalizing the denominator and we just multiplied by that same radical, we just got what was under the radical, and then the radical disappeared. That may have sounded confusing, so let's do a couple more. So if I want to rationalize this new example, I'm going to multiply by root 4x and root 4x. So if we apply that pattern that we learned up here, root 4x times root 4x, after all the simplifying is done, that's just going to give me 4x. And then root 7 times root 4x is going to be square root of 28x, which this one can be simplified. So we have the square root of 7 times the square root of 4 times square root of x over 4x. So the square root of 4 is 2, so that 2 is going to come out. And then I have a 7 and x, and those aren't going to be or contain perfect squares. So 2 root 7x over 4x would be your answer. So again, if I was going to be multiplying root 5x times root 5x, that's just going to simplify to 5x. If I had root 6x times root 6x, that's going to simplify to 6x. So there is a little bit of a shortcut. You don't have to show all of your work unless your teacher makes you, because I do with my students sometimes. But this would be acceptable for showing your work, because once you see the pattern, it would be unnecessary to write this as 25x squared, which is the root 25 times root x squared, which is just going to be 5x. So that just seems a little bit extensive. If you can see the pattern, then go ahead and apply it. Okay, so let's do some more practice problems with rationalizing the denominator. And I encourage you to pause the video, work out one problem, and then restart the video to check your work. So to rationalize the first one, you're going to multiply by root 5 to the numerator and the denominator. That will give you the square root of 5 over 5, which is your final answer. And just to remind you, square root of 5 times the square root of 5 is the square root of 25, which just simplifies to 5. Okay, so next example, we're going to multiply by root 3 on the top and the bottom. This will give me the square root of 30, and then root 3 times root 3 is just going to give me 3, because root 3 times root 3 is root 9, and the square root of 9 is 3. Root 30 doesn't simplify, so this is your final answer. On the next one, you're going to multiply the numerator and the denominator by root 6. This will give you 4 root 6 over 6. And then for this one, the root 6 will not simplify, so we just want to check to see if we can simplify these whole numbers, which both of them are divisible by 2. So that would give me 2/3, and then the root 6 would be unchanged. Your last example, we're going to multiply by root 13z over root 13z. This is going to give me root 13z over 13z. This would be your final answer.